In this video, I would like to go over a couple of different pulley examples. This first example is shown with this pulley. We have two different pulleys, one right here, and we have one cord that is attached to both of these pulleys. We are going to pull down at point A, and we are going to pull down point A at 2 meters per second, and we are asked to figure out what the velocity of B is. So the first thing we want to do is we want to establish a reference datum, and this point right here is a good point to establish this datum because this pulley is fixed to a structure. So then we know that from that reference datum to point A, wherever point A may be, since it could change with time and change when we pull it, it's going to have a distance of SA. And when we measure from our reference datum to point B, we get a distance of SB. And like we've done before, this distance over this pulley right here and this rope distance over this pulley right here can be neglected because the length of cord that is always over this pulley is constant regardless of how these pulleys have moved and where the block is. The length of cord over the pulley is always a constant. So we start at one side of our cord, and we just record the length of the pulley as we go. So if we start at point A, we have a length of SA, and we come over here and we have a length of SB. And we come around here and we have another length of SB. And this is equal to some length of a cord, L. Now if we simplify this equation a little bit, we get SA plus 2SB is equal to L. And if we differentiate to get the velocity, we get velocity of A plus 2 times the velocity of B is equal to 0. We get a 0 because this length is a constant. The length of the rope that we're looking at does not change with respect to time, and so when we differentiate a constant, we get 0. And we are given that the velocity of A, VA, is equal to 2 meters per second. We know that this is a positive 2 meters per second because A is pulled down, so A is moving in this direction, and our positive distance is also in this direction because of how we're referencing our problem, the positive down. So if we look at our numbers and we solve for VB, we get VB is equal to minus VA over 2, and if we plug in what we know for VA, the 2 meters per second, we get minus 2 over 2, or minus 1 meter per second. So the velocity of B is moving at minus 1 meters per second. If we look at this example, since our positive direction is down because we're referencing from this point, VB is moving at a minus 1 meter per second, so VA is moving upwards. And since this makes sense because it's opposing our positive direction, so it is minus 1 meters per second. So the velocity of VB can also be VB is 1 meter per second in the upward direction.